Let's talk about the security model for the agent economy wallet. So this diagram illustrates a highly secure cryptographic flow for protecting sensitive data, specifically taking plain text, plain text cryptographic key pair, like a Solana wallet in this case, and locking it safely inside a JSON file using a password. So as you can see, it is broken down into two distinct key phases, the key derivation phase and the encryption phase. So let's discuss this key derivation phase. So normally you can't use human readable passphrase directly as an encryption key. They are too short, too predictable, and they don't match the exact byte length required by modern encryption algorithms. So what this does is it takes the passphrase and a random sort. So the user's passphrase is combined with the random sort. A sort is a string of random data added to the password before hashing. So this sorting ensures that even if two users have the same exact passphrase, their derived keys will be completely different. So it takes the passphrase and the random sort and passes it to this PBKDF2, which stands for the password based key derivation function. So after it has passed it to this PBKDF, it runs it through this HMAC SHA algorithm 210,000 times. So why 210,000 times? Basically, this makes the computer um, forces the derivation phase to take a fraction of a second. To a normal user, this delay is unnoticeable, but to a hacker trying to probably use brute force billions of password combinations in a second, this is actually a delay. So that intentional delay makes cracking the password impossible, computationally impossible. And the output would be the derived key of 32 bytes or 256 bits. So the next phase would be the encryption phase, and the encryption is done as shown here. So I'm going to center this a bit. Right. Okay. So it takes two inputs again, a plain text key pair, which is the secret we want to hide, which is our um, Solana secret key or the Solana private key or the wallet private key. So it takes um, a plain text key pair, which is the Solana. Now, this plain text key pair is the private key for the agent's wallet address. The second parameter it takes is the random IV or the random initialization vector. So this initialization vector ensures that even if you encrypt the exact same key pair twice, the resulting ciphertext will look completely different every time, preventing some form of pattern recognition. The cipher, which is the AES 256 GCN, uses the advanced encryption standard. So the AES means advanced encryption standard with a 256-bit key length. The GCN part, which is the Galio's counter mode. So the GCN part is an authenticated encryption mode. It doesn't just encrypt the data; it generates a cryptographic signature to prove the data hasn't been tampered with. Now the output would be a ciphertext and an auth tag, and all of this would be saved to the key store JSON. So where the integrity of the agent's wallet is protected. So now let's see this entire operation in action. So I'm going to go over to the docs and I'm going to encrypt the master wallet secret key. So the master wallet secret key is basically the wallet that funds the agent's wallet at the point of creation. So this is documentation, and I have done step one, step two, step three, and I've copied the env variables. So now let's follow this step to encrypt the master wallet secret key. So going over to my code editor, as you can see, I have copied everything to the env file. Everything is set. I'll change the wallet passphrase. Okay, let's follow it step by step instead. So the first one is paste your base 58 private key into the master wallet secret key in the env file. So as you can see here, the master wallet secret key, the base 58 private key is pasted in the master wallet secret key with the master wallet secret key variable. Yeah. So the next step would be to um, so the next step would be to run pnpm key import. I'll copy this, and this key is encrypted with your wallet passphrase and saved to this directory. So the wallet passphrase here is, I'll just change it to a strong password. A very simple thing like I love my I love my wallet. Let's go with what it recommended. So after that, I'll run pnpm key import to run this encryption. So as you can see, this stuff is successful. It migrates the raw base 58 private key from the .env into the encrypted key store. The master wallet, the founder wallet is encrypted and stored as master founder. So this is done. The next step is to update the env. So I'm going to remove this file and add this instead. So with this, the master founder will act in place of the raw private key due to this whole encryption process. So I'm going to bring this down here. I'm going to remove this, and I will uncomment this. So let's go back to our steps. So delete or comment, which we've done. Set the master key label in the label you choose. The default is master folder, which we've done. And then we clear our share history to ensure the key isn't stored in memory. So I'll go back to the terminal now. Please. Then I forgot to copy this. So I'll copy this to clear the share history. So everything is clear. So we can see the rigorous process that is being taken to ensure that this wallet's private key is not exposed to the agent or any attacker. So now that we've run the whole encryption process, let us see how this would look like. Let us see the shape of the JSON file of this key encryption. So I'll go over to the directory where it is being stored. So we can see the JSON file that's is storing the whole key pair encryption and decryption stuff. So if I should click on this to, I should open this with VS Code. I'll close this, then. So it's opened with VS Code now. And we can see that this is the ID, label is the master folder, which is what we set. The public key of the base 56 private key. The public key of the Solana private key is this guy, and we can see the cipher. We can see the cipher text. The KDF is using PBKDF to just basically all we explained earlier in the video. The iteration is 210k. You can see the salts. Yeah, basically we can see everything. So this is what the whole system would use to decrypt the private key when it's using to sign the transaction. So anytime a transaction is being sent, or anytime the agent wants to execute a transaction or an instruction, and it requires the its private key, this whole stuff will be used for its decryption. So if you remember the passphrase we set in the EMV, which is I love my wallet. So that when it's time for decryption, that passphrase together with the random salt, just the random salt. Yeah, this is the salt, right? So that passphrase together with the random salt from this keeper.json file will be passed through this PBKDF to get the derived key, which is 32 bytes. So that derived key with this cipher text, then with this IV, which is the initialization vector, will be passed through the ES256 GCM. Where is it? Which is this guy, this cipher. Then calculate the expected auth tag. Then basically, if the tags match, right, it will be successful. So the keys will be open for the wallet to sign the transaction. But if there's a mismatch, there'll be an error message.